Okay, so let's delve a little bit more into where things are going to be written. And over here we write to the array. And we're going to immediately say what the value is that we entered. We just got it. And where it's located. And then in this loop over here, we're going to read those numbers. Okay, so over here, first we're going to show what is in the array before writing. We have declared it here. And since we have not initialized it with any values, we're just going to have some garbage data there. The array has a size of 5, so that's enough, but not too big. The first thing we'll do is state where the array is going to start, which memory location, and then we're going to show all the memory locations over here, and then we're going to write and show where it is written, and then over here the values that we entered. Okay, so the array starts at memory location hex 5FFE70, and you see that over here we have 70, 74, 78, 7C, which is 7 and 12, and then it goes over here to 80 because 12 plus 4 is 16, which is 0 with over here a carry of 1 to take it from 7 to 8. Okay, so now we have the memory locations for the 5 elements in the array. And like we discussed, we neglected over here in the writing to use the ampersand. So I'm going to give it some values: 77, 44, 11, 55 and 66. So you see that over here the 77 is going to be written to FE6C. Same thing over here, same memory address, same memory address, same memory address. What that means is that each number is written to the same address and they overwrite each other. Also notice over here that FFE6C is nowhere near, it's in fact a little bit before these numbers over here. Actually, now that I look at it, you see that 6C is right before the 70, because if you add 4 to this for an integer, your C is 12, plus 4 is 16, which is 0 carry 1, so this becomes 70. So it looks like it's going to go to the memory address right before the array. Okay, and then if you want to see what's in the array again, you start over here with the 70, the 74, 78, 7C and the 80, just like we had over here, and you see that this is just identical, and it means that when we write these values over here, we're actually writing them to the memory address right before the array. Let's see what would happen if we want to fix this. And for the writing, we're just going to use the ampersand again. Okay, and now we're going to do 55, 66, 77, 88, 99. So first memory address over here, E60, and we write to E60. Second memory address, E64, write to E64. E68, we write to E68. And you see that we entered 55, 66, 77, 88, 99, and those values are properly stored. So that shows you the power of using the correct ampersand when you write. You'll write to the correct spot.